Hello, this is Yashwin. In this video, I'll be solving paper 4, variant 2, February-March 2019 0620 chemistry. Starting with question number 1. Petroleum is a useful natural resource. The diagram shows how petroleum can be separated into useful substances. A. What is the name of the separation process shown in the diagram? Alright, so this is fractional distillation. B. Name the fraction leaving at A. So A is naphtha, and B is bitumen. C. Refinery gas is a mixture of hydrocarbons. One refinery gas is butane. 1 suggests the names of 2 other refinery gases. So they have to be below pentane, since pentane, starting from pentane and going further, the hydrocarbons turn into liquids. So it can be from methane, ethane, and propane. I'll go with ethane and propane. Due to having shortest chains, the initial 4 alkanes are the only hydrocarbons which are gases at room temperature, and that is why they are the refinery gases over here. 2. Write a chemical equation for the complete combustion of butane. Alright, so we have C4H10 plus O2, which gives carbon dioxide plus water as the results. Alright, so we have 2 over here, 13 oxygen molecules and 8 carbon dioxide molecules, followed by 10 water molecules. 3. Name the toxic gas produced by the incomplete combustion of butane. This carbon monoxide. D. Gasoline and kerosene are both fuels. They have different properties. 1. Describe the difference in the properties given. Viscosity of the fuel. So this is the thickness of the fuel. As the length of the carbon chain increases, so does the viscosity of the fuel. And since the kerosene has the longest carbon chain, it is going to be having a viscosity greater than gasoline. And so due to a longer length of the carbon chain, flammability decreases with the length of the carbon chain, which means gasoline has a shorter chain, and so it is going to be more flammable. Two, what difference in the molecules of gasoline and kerosene causes these difference in properties? Alright, so the length of carbon chain or rather the difference in length of carbon chain. E. Hydrogen fuel cells can be used to power vehicles. Write the word equation for the overall reaction that takes place in a hydrogen fuel cell. So hydrogen burns in the presence of oxygen, and the only product is water. Question number 2. The aluminium is extracted from its ore. The ore is converted into pure aluminium oxide, which then undergoes electrolysis as shown. A1. Name an ore of aluminium. This is bauxite. 2. What is meant by the term electrolysis? So we're supposed to be writing the definition of electrolysis over here. B. Aluminium oxide has a melting point of about 2000 degrees Celsius, but the electrolysis process operates at about 900 degrees Celsius. 1. Name the compound added to aluminium oxide to reduce the operating temperature. This is cryolite. 2. Suggest one benefit to the environment of reducing the operating temperature. So reducing the operating temperature reduces the amount of carbon dioxide which is emitted. So it decreases. Three, write the ionic half equation for the reaction taking place at the electrodes. Alright, so the negative electrode is going to be attracting the positive ion, which is aluminium in this case. Aluminium has a charge of 3 plus, which means it has 3 more protons than electrons, and so it needs 3 electrons to make it a neutral atom. So we'll be adding 3 electrons, and so the 3 negative charges cancel out the 3 positive charges over here, resulting in a neutral atom. Similarly, so the positive electrode attracts oxygen ion. Each oxygen ion has a charge of -2, but since oxygen exists in in the form of diatomic molecules, we'd have 2 oxygen ions deposited at the anode to form 2 oxygen molecules in the end. So the 2 molecules of oxygen would have a total charge of -4, and so they need to take out 4 electrons over here to make it a neutral atom. Or explain why the anodes need frequent replacement. That's because the carbon in these anodes, they're basically made from graphite or another form of carbon. They react with the oxygen which forms at anodes and react with them, forming carbon dioxide, and this dissolves the anode. And that is the reason they have to be replaced. C. Aluminium oxide reacts with acids and with alkalis. What term is used to describe an oxide that reacts with acids and alkalis? That is an amphoteric oxide. 2. Aluminium oxide reacts with dilute sulfuric acid to form a salt. State the name and write the formula of the salt form. So this should result in aluminium sulfate. Right, proceeding to the formula, we start by writing the symbols of the elements in the compound or the ion if you have that. So aluminium has the charge 3, has valency of 3, and sulfate ion has the valency 2. We cross the valencies with the names of the compounds or ions, which results in Al2SO4 and 3 sulfate ions. 3 aluminium oxide reacts with dilute sodium hydroxide to form a salt and one other product. Name the other product. So the other product is water. 4 aluminium hydroxide decomposes when heated to form aluminium oxide and water. Write the chemical equation for this reaction. Alright, so we have aluminium hydroxide decomposing to aluminium oxide plus water. Since we had three hydrogen molecules over here, we'll balance by making it 6 over here, similarly 6 over here. 5 suggests the names of 2 other aluminium compounds that decompose when heated to form aluminium oxide. So those are aluminium carbonate and aluminium nitrate. Moving on to question number 3, the periodic table. The periodic table is a method of classifying elements. Identify the element which is in group 4 and group 6 and period 4. That is selenium. Groups are arranged vertically and periods are arranged horizontally. B. Calcium is in group 2 and chlorine is in group 7 of the periodic table. Explain in terms of number of outer shell electrons and electron transfer how calcium atoms and chlorine atoms form ions. Give the formula of the ions formed. Alright. Starting with number of electrons in the outer shells. So calcium has 2 electrons in its outer shell. And it loses those 2 electrons to gain a charge of 2 plus. Alright, so we have to give the formula of the ions and forms the ion Ca2 plus, and chlorine has 7 electrons in its outer shell. Alright, that's it. C. Group 5 chlorides are covalent molecules. The boiling points of some group 5 chlorides are shown. 1 suggests the approximate boiling point of phosphorus chloride. So it has to be somewhere between 71 and 130. I'll go with 80 degrees Celsius. 2. Explain the trend in boiling points in terms of attractive forces between particles. So as the attractive forces between particles increase, So the stronger the attractive forces, the greater the energy the compound needs to break them, and so the boiling points increase. C. Complete the dot and cross diagram to show the electron arrangement in a molecule of phosphorus chloride. Show outer electrons only. So phosphorus is a group 5 element, which means it has 5 electrons in its outer shell, and it needs 3 extra electrons, and it's going to be getting them from the 3 chlorine atoms, and each chlorine atom has 7 electrons in its outer shell, so it only needs one to complete it. And so the three of them are going to be sharing 1 electrons each with the phosphorus atom. Alright, so phosphorus has 3 bonds with each of the chlorine atoms. Chlorine has 7 electrons. So the 7 dots over here, or you can call them circles, are the chlorine atoms, and these X electrons are from phosphorus. So all chlorine atoms now have complete outer shells. Phosphorus has 2 remaining electrons of its own, and so phosphorus also has a complete outer shell now. D. Phosphorus chloride reacts with chlorine to form phosphorus chloride with 5 chlorine atoms. This reaction is exothermic and reaches an equilibrium. 1. Describe 2 features of an equilibrium. Alright, so an equilibrium has forward reaction, which is equal to the backward reaction, and concentration of reactants and products does not change. To state the effect, if any, on the position of this equilibrium, when the following changes are made, explain your answer. When temperature is increased. If forward reaction is exothermic, that means backward reaction is endothermic. So if the temperature increases, backward reaction is favored and equilibrium shifts to left. So equilibrium over here. Pressure is increased. So pressure always favors the side with the lowest number of molecules, which is the right hand side, and that means the equilibrium is going to be shifting to right hand side. And the reason is that the side with greater number of molecules in this case is the reactant sides, and so the number of collision would be greater on this side than the product side, which results in greater yield of product than the reactants. So the answer is three. Explain in terms of particles what happens to the rate of forward reaction when the reaction mixture is heated. Increasing the temperature would result in increased rate of reaction of any reaction. So once the molecules gain kinetic energy, they're going to be moving faster, and so the collision rate would increase, and that basically means the rate of reaction increases. E. Phosphorus chloride reacts with lithium fluoride to form lithium phosphorus fluoride. Calculate the mass of lithium fluoride needed to form 3.04 grams of lithium phosphorus fluoride using the following steps. Alright, so the first part is calculate the number of moles of lithium phosphorus fluoride. Moles is equal to mass, which given in the question is 3.04, divided by molar mass, which is given over here, 152. So that is equal to 0.02 moles. 0.02 moles. Reduce the number of moles of lithium fluoride needed. Again, the term reduce over here means we're supposed to be using the ratio given in the question. So it says 6 moles of lithium fluoride give 1 mole of lithium phosphorus fluoride, which means 0.02 moles multiplied by the number 6 over here would give the figure of moles of lithium fluoride over here. That is 0.02 multiplied by 6 is equal to 0.12 moles. Calculate the mass of lithium fluoride needed. So mass is equal to 0.12, the number of moles multiplied by the MR, of which lithium fluoride has is 19 plus 17, the relative atomic masses of lithium and fluorine, and this is equal to 3.12 grams. Lithium fluoride has ionic bonding. What is an ionic bond? So it is a bond due to attraction between oppositely charged ions. Two give two physical properties of ionic compounds. So they have high melting points, melting or boiling points, and they are also soluble in water. Question number 4. Iron is a typical transition element. Iron acts as a catalyst, forms colored compounds, has more than one oxidation state. A. Name one major industrial process that uses iron as a catalyst, and name the product made in it. So it's used in Haber process. B. When aqueous sodium hydroxide is added to aqueous iron sulfate, a precipitate forms. 1. What color is this precipitate? This precipitate, which is basically iron hydroxide, is green in color. 2. Write the ionic equation for this reaction. Include state symbols. Alright. So to write this ionic equation, we need to start by writing the ions which form the precipitate over here. The precipitate, which is iron hydroxide, needs the ions iron, which over here has the charge of 2 plus, and also the hydroxide ion, which has a charge of -1. So we need two hydroxide ions to cancel out a single iron charge over here. Since 2 plus can be cancelled out by 2 minus, and both of them are in aqueous form, which is crucial because given in the question. And so this results in the precipitate iron hydroxide. In solid form, C. Iron sulfate can be converted to iron 3 sulfate by potassium manganate at room temperature. One, what is the role of potassium manganate in this reaction? So potassium manganate over here is oxidizing iron, which means it is acting as an oxidizing agent. Two, what condition must be used for this reaction to occur? So whenever potassium manganate is used as an oxidizing agent, it requires the presence of an acid. 3. In terms of electron transfer, what happens to the iron or ions in this reaction? So they lose electron and gain another positive charge. From 2 plus, they get converted to 3 plus. 4. State the color change seen during this reaction from purple to. So the color change over here occurs due to potassium manganate, which is from purple to colorless. D. Deduce the charge on the iron ion in each of these compounds. Fluoride is a group 7 element, which means it has a charge of -1. And given over here, there are 3 fluoride ions, which means the total charge of fluorine atoms, fluoride ions, is going to be 3 negative. So how many po- positive charges do you need to cancel out 3 negative? Well, you just need 3 positive charges to cancel out 3 negative charges. And since here there is only one iron atom, that indicates that this one single iron atom or iron ion is enough, has a charge enough to cancel out 3 negative, and that charge is 3 plus, because 3 plus and 3 negative are going to be equal to 0. So that is how you work out the charges. And similarly over here, nitrate ion has a charge of -1. But since there are 3 negative ion, this means the nitrate ion has a total charge of 3 negative. So how many charges do you need to cancel out 3 negative? You need 3 positive charges. And so the iron over here, one iron atom should have a charge of 3 plus to cancel out all of those 3 negative charges. Question number 5. There are two types of polymers. A. Addition polymers are made from many identical small units. 1. What is the term used to describe these small units? Well, these units are called monomers. 2. A section of an addition polymer is shown. Draw the structure of the small unit used to make this addition polymer. Show all of the atoms and all of the bonds. So as you can see over here, this is where the structure of the monomer is repeating. These two groups are different from each other, which means this is the part which is the monomer. And so this should be as in the form of this compound. But we're supposed to be showing all of the bonds, which means the bonds are going to be as such. Alright, so I forgot to mention the only change over here is going to be a double bond between these two between these two carbons, and the rest remains the same except you exclude these single bonds on both sides of carbon. So we have CH3 with 3 hydrogen atoms, followed by another carbon atom. The polyamides are condensation polymers. What does the term condensation mean when used to describe this type of polymer? So it basically means water is present in the products. C. A polyamide can be made from two different molecules. A simplified structure of octanidoic acid is shown. A simplified structure of 1,6-diaminohexane is shown. 1. Complete the diagram to show a section of a polyamide manufactured from the octanidoic acid and 1,6-diaminohexane. Include all of the atoms and all of the bonds in the linkages. Alright, so over here, this alcohol group removes hydrogen and oxygen over here, and only hydrogen is removed from the diamine group, which results in the formation of the protein or the amide linkage. Similarly, O and H are removed from here and another H. So these two and these two combine together to form the water molecule, which is the byproduct of condensation polymerization. And so the main product is as follows. We have nitrogen with only one of the hydrogen from its previous form. Similarly, we have the second nitrogen, and now it's going to be bonded to this carbon atom. All right, so the double linkage with oxygen remains as it was. It is going to be the same on the other side. Now this carbon atom is going to be bonded to the next nitrogen, and so it goes the same way. And so the link goes on and on. So this one over here is the amide link. You don't have to label it, I'm just indicating it. So we have 3 amide linkages. To state the name of a synthetic polyamide, this is nylon. Alright, so we are done with this paper. Thank you for watching.